Hello, this is Tyler Beamer. This is a instructional math video for DMA 030. This particular video is in regards to Section 3, Proportions and Problem Solving. And I want to do a few examples here that are applied in which we can solve using proportions. So one direct application of proportions is map reading. So if you have ever looked at a map or used a map either for driving or let's say you're backcountry hiking or whatnot, a map is a scaled down version of an exact place, and so we can use the legend and the scale on the map in particular to determine what real life distances are from the map. So here's an example of that. So on a Chamber of Commerce map of Abita Springs, 5 miles corresponds to 2 inches. So that's on the map, right? So if I measure 2 inches from one place to another, in real life that's actually 5 miles. So that's what that is, what the first sentence is describing. So how many miles corresponds to 7 inches? So let's say I got to go 7 inches on the map. How far is that going to be in real life, so that I can obviously plan and prepare. So we can certainly set up a proportion here. One thing to keep in mind is that we want to make sure that our proportions are consistent on both sides. So we're going to write two ratios, and it's going to have inches on the map as the numerator, and then miles as our denominator. And I want to make sure that I'm consistent here in writing this proportion, so that when I write the ratio on the left hand side, inches on the map is the numerator, miles is the denominator, and then when I also write the ratio on the other side, it's consistent, and inches on the map is the numerator, miles is on the denominator. So we wouldn't want to have inches on map as the numerator and miles on the denominator on the left, and then on the right this be flip-flop. That would not work for us. That'd give us an inaccurate answer. So that's really, really important, and you want to do that for any proportion problem that you're solving. Alright, so let's take the information from our problem. So the first sentence gives us one ratio because we're comparing these two quantities. The amount of inches on the map, which is 2, is getting matched with 5 miles in real life. So that comes from the first sentence. We can compare those two quantities. And on the other ratio on the right hand side, how many miles? So the miles here is going to be unknown. So anytime we have something unknown, we can represent that with a variable. So x miles corresponds to 7 inches on the map. Notice that I'm keeping my units consistent here. So now I just want to solve this for the missing variable, which in this case is x. So I can cross multiply to do that. So 5 times 7 gives me 35, and then I set that equal to the other cross product, which in this case is 2 times x, or 2x. And then remember, to solve for our variable x, we want to divide the number that is not with x by the number that's in front of x. So 35 divided by 2 equals x. And then I can actually get a decimal answer here, 17.5 miles. And the units are important here. Whenever you get done with any type of word problem, you want to make sure that your answer makes sense, and having the units there helps you determine that. So, if 2 inches on the map corresponds to 5 miles, then obviously if I have 7 inches on the map, I should be going more miles in real life, and I am 17.5. That seems to be in the ballpark, right? The answer is not too large, you know, and it's not too small, so that makes sense. All right, so that's one direct application of proportions. So here is another direct application. So I believe we've got misspelling here. It should be dose. So the standard dose of an antibiotic is 3 cc's for every 50 pounds of body weight. At this rate, find the standard dose for a 130-pound woman. So obviously this is a direct application if you are going into a health profession, nurses. Obviously you want to make sure that you give patients the correct amount of medicine. You know, too much medicine and there could be dire consequences, and too little medicine and the patient may not get well. So once again, we want to set up the proportion so everything's consistent. So I'm going to put cubic centimeters of antibiotics as the numerator and then pounds as the denominator. So I want to make sure that both sides are set up the same way. So the first sentence here tells me that someone who is 50 pounds should get 3 cc's of antibiotics. So that's one ratio. We're comparing those two quantities. And then the other ratio at this rate, find the dose. So X number of cc's for a 130-pound woman. So that's what our proportion is going to look like. Notice that we're keeping everything consistent. cc's as the numerator, pounds as the denominator. Using the information from the problem here. Setting up those ratios. So now we want to solve for X. So do our cross products. So 130 times 3 gives us 390 equals 50 times X, or 50X. And then we want to solve for X, so divide 390 by 50. In order to do that, so we get 7.8. And these units are cc since we're solving for antibiotics. So, you know, that answer is in the ballpark. It makes sense. If a 50-pound person needs to get 3 cc's, then obviously a 130-pound person should get more than that. And our answer is more than 3. It's not too large, you know, and it's not too small. So seems like it's accurate. So that's always a good thing to do after you solve these problems, is ask yourself, does my answer make sense? Okay. So here is our last problem. Okay. So a 50-pound bag of fertilizer covers 2,400 square feet of lawn. So how many bags of fertilizer are needed to cover a 2 square containing 15,360 square feet of lawn? Okay. So important information in the problem is that we need 50 pounds of fertilizer to cover this many square feet of lawn. Right, so obviously this has direct application if you're in lawn care business, you know, or other potential applications that are similar. You know, put too much of this down on your yard and you're going to kill it and waste your money. Too little and it's not effective. So we're comparing in these ratios pounds of fertilizer to square feet. So I'm going to set up our proportion. So the first ratio comes from that first sentence. We need 50 pounds for 2,400 square feet. All right. So then how many bags, and we're going to get to this point here in a minute. All right, let's first figure out how many pounds we need, and then we'll figure out how many bags. So we're going to say X pounds to cover 15,360 square feet. So once again, cross multiply. So 50 times 15,360, I get 768,000. 2,400 times X. Divide 768,000 by 2,400 to get X. So I get 320 pounds. Okay. So that's how many pounds of fertilizer I need, but that's not the answer to the question. The question says, how many bags do I need? Well, I know that there are 50 pounds in each bag, so if I divide 320 by 50, that will then tell me how many bags of fertilizer I would need. So I need 6.4 bags of fertilizer, and of course I cannot buy partial bags of fertilizer. I can't go to the store and buy 0.4 of a bag. So in this case we would round up. We know we're not going to follow normal rules of rounding because it's an applied situation here. So even though this is less than 5, I'm still going to round up to 7. Just because I need an extra bag to cover that partial amount that I need, and I can't buy partial bags of fertilizer. So then we would need 7 bags, and so that would be our answer. So that one was a little bit more involved. So all right, hope this video helps. As always, if you have questions, email or come by the office. Have a great day.